In living things. Your body is an ecosystem. It is called the human microbiota. Can you say microbiota? Microbiota! That's what we call this ecosystem that your body makes up. So you're covered in skin mites. They're munching on those dead skin flakes. Now, okay, your human microbiota. I said you are covered in critters. You've got bacteria, you've got fungi, you've got these mites. This is the microbiota. Where do you think most of these organisms live? Do we have any ideas? Like, where are most of those organisms living? Do you have a guess? You can't guess wrong. On your arms! That's a great guess.
On your skin.
On your arms. It's actually something on the inside of your body. Do you have another guess? What'd you say? Your bones! Another great guess. What did you say? Throat? We're going in the right direction here. We're talking about your guts, your gastrointestinal tract, your guts. Yeah, this is where most of that microbiota lives. So let's talk about the guts. Your digestive system is what goes from your mouth to the other end. It's how food travels through your body, right? And it's not a straight shot. It's actually full of twists and turns. So we're going to take a deeper look inside the skin now. Let's go inside. We're going to follow this pathway that food follows through your digestive system. So this starts at the mouth. Food enters your mouth, your teeth, your saliva, they mash up your food, and then it starts to travel into your body, into your esophagus, which is about 12 inches long. Your esophagus is the pathway that food makes from your mouth down through a set of muscles that act as doors into your stomach. And then your stomach is a bag of acid. And with muscular actions, it's moving, it's grinding that food into a paste that then makes its way into the small intestine. This is not small at all. It's still going. Oh my goodness, how much is in here? Whoa! Okay, there we go. This is your small intestine, which, contrary to its name, it's not small at all. It ranges from 11 to 20 feet in length. Your small intestine is where all of that paste, all of that mush that's made its way this far, it continues to be broken down and it absorbs nutrients from your food. And then all of that food makes its way into the large intestine, which is not nearly as big as the small intestine, but it is where most of those microorganisms live. So this is the large intestine. It's maybe about 5 feet long, and it absorbs water before that food is turned into waste, right? So this is massive. How does all this fit inside of us? This is crazy long. Can we stretch this out and see how long it is? Can I hand this to you? Okay, perfect. Can you hold on to this end? Yeah, okay. And then we're going to stretch this thing out. Can I hand this to you? Yeah, hold on to that. And then we're going to just drape this across and maybe come all the way up to here. Here, can you hold on to that end for me? That's long! Your guts, your digestive system is about 25 feet long in total. That's crazy. Can you believe all of that fits inside of you in your tummy? It's crazy, right? Here, I'll take it back. Thanks for holding on to the intestines. Thank you for having the guts to do this, you guys. I know it's a little bit. Thank you. I'll take it back. Thank you so much for helping me out. Whew, okay. So this is a lot. This is your gastrointestinal tract. Now you might be wondering, how does food move through this? How does food move through this system? Is it gravity? How does food move through this? It's a muscular action. Yeah, totally. Your food is moving through your digestive system. It's because of this thing called peristalsis. Let me show you an example of peristalsis. First, actually, I forgot this is in here. This is a video of the inside of your digestive system. So this would be the food's point of view as it travels through your esophagus. So, like we said, how does the food move through your digestive system? Through a system called peristalsis. And this is an example of peristalsis. Here it comes. This is a worm. This is an earthworm. Have you ever seen an earthworm wiggling around in the dirt? Mm-hmm. They move. They also move using peristalsis.
I like touching them.
You like touching worms? Yeah, right? So worms move. Yeah. So worms move using peristalsis. Peristalsis peristalsis is a smooth muscle action. It's involuntary. This is the same way that food makes its way through your digestive tract. It's a smooth, involuntary muscle action. So what does that mean? It means you don't have to think about it. You don't have to tell your body to digest food, right? It does it automatically. There are a whole bunch of other actions in your body that happen involuntarily, like breathing, right? Or pupils dilating. Your iris in your eyeball, the part of your eye with color, it's a muscle. And it opens and closes without you thinking about it. So these are all involuntary muscle movements. They're smooth muscle movements. Or even your blood moving throughout your body. That's involuntary as well. But that's because of a different kind of muscle. That's because of the cardiac muscle. It's another kind of muscle in your body. Do you have any guesses as to where cardiac muscle is found?
The heart.
The heart, yeah, absolutely. Cardiac muscle is found in the heart. So your heart is a really strong muscle that pumps blood throughout your body, and it's really resistant to fatigue. That's why your heart can beat forever, right? It's really resistant to fatigue. So these cardiac muscles, we're gonna check out how they work. I've got something over here. This is called an ultrasound. Has anybody ever heard of an ultrasound? Yeah, so we're gonna boot up this ultrasound over here and take a look at some of this cardiac muscle movement in my own neck. So what I'm gonna do is show you my carotid artery. So this is how blood is supplied to the
Oh my.
Well, that wasn't supposed to happen. It's fine though. Surprise! So I am about to show you my carotid artery. You see all that movement?
Mm-hmm.
There we go. Yeah, it's actually inside of my neck. So this is called an ultrasound. So ultrasounds work by producing high-frequency sounds and sending them into the body, and then they bounce off of things inside of me. And then that creates this image that then we can look at. And what you're seeing right now is my carotid artery moving because of cardiac muscle movements. Your carotid artery supplies blood to the face and to the brain. You've got one on either side of your neck. Now, let's take a look at the pulse at which it's moving right now. And let's see if we can speed it up. Ready? Okay, maybe let's see. Hey, yeah, it's moving a little bit faster. So this ultrasound let us see your cardiac muscle. So we've talked about those smooth muscles in your digestive system and cardiac muscles, but there's one other kind of muscle in your body, and it's called skeletal muscles. Now, these are the muscles you probably think of when you hear of muscles. Skeletal muscles are attached to your skeleton, and it's what allows me to move around. When I just did all those jumping jacks, I'm moving around because I'm using my skeletal muscles and my bones. So skeletal muscles, like I said, it's typically what you think of when you picture a muscle. They often come in pairs because they can only pull, they can't push. Let me explain what that means. When I curl my arm like this, my bicep is pulling, and then when I go the other way, my tricep is pulling. So bicep and tricep come in pairs, right? So skeletal muscles come in pairs. Let's go back to our slides here. Now, this brings me to your bones. We have to talk about bones, right? Your skeletal muscles are attached to your bones. It's the structure of your body. You actually have 206 bones inside your body total. Babies have a lot more. They have 270. As you get older, those bones fuse together, right? So you have 270 as a baby, and then adults have 206 bones. Over half of those bones are found in your hands and in your feet. That's why you can do things like knit or play piano or do sign language, right? Everybody wiggle your fingers, yeah. Yeah, you've got 106 bones in your hands and your feet. Now, bones range in size. Actually, your smallest bone, it's in the ear. Let's see if I can pull out the smallest bone here. Let's see, I'm gonna go in like this. Yeah, it's in your ear. It's really small. I don't think you can see it. It's called the stapes. Your stapes is in your ear. It receives vibrations from the air, and it sends them all the way to your inner ear. So your stapes is your, save that for later, your stapes is your smallest bone. Your biggest bone in your body is your femur. It's also your femur. It's your biggest bone, it's the strongest bone, and it's the heaviest bone. Your femur can support up to 30 times your body weight. So that's about the size of a rhinoceros. You could put a rhinoceros on top of your femur, and it wouldn't break. This doesn't mean that bones are invincible, though. Has anybody ever broken a bone? That's great. That's really good.
Yep.
Yeah.
Yep.
Oh no! Yeah, well, I bet a bunch of you have broken bones, right? Because bones are not invincible. There are a whole bunch of different kinds of bone breaks. There's something called a hairline fracture. That would be a smaller break from repeated stress on a part of the bone. There are also bigger breaks, too, like a closed fracture. That would still be under your skin, or even an open fracture. So bones can sometimes pierce through the surface of your skin. That is called an open fracture. Now, don't worry, bones are really good at healing themselves. If you've had a broken bone, you're probably okay, because they can heal themselves quite well. At the site of the break, blood starts to clot. It almost forms a scab. It gets inflamed, and then the bone can regrow and heal itself. Sometimes bones need a little bit of help, though. Oh wait, that's not what I meant to do at all. Hold on, we're gonna go back here. Maybe not. Let's see. Oh no! It's covering it. Let's see. How do I get out of this? There we go. That sort of works.
Mm-hmm.
Oh no. I'm gonna call up a tech assistant. Give it up for Willow. Tech assistant Willow. Thank you so much. So, like I said, sometimes your bones need a little bit of help when they start to regrow. Has anybody ever had a cast? Have you ever had a cast? Yeah, or even pins. Sometimes pins are used
In my
to
arm.
help bones get back into place. Willow's currently working on our technology issue here, but this is actually my own personal x-ray. I broke my bone. I broke my radius. It's in my wrist right here, and it is currently being covered by our little window here, causing a technology issue.
To be clear, there is no exit.
But I broke my radius, and I had to have pins.
No menu. But it takes us back. I'm hitting menu, y'all.
Oh.
We're just gonna do it this way. Stay alive.
Unplug it.
Plug it back in.
Yeah, not an arrow.
Well, thanks for your help, Willow. It's okay.
The people who-
Don't worry about it. It's all good. Okay, that's fine. Don't worry about it. So the point is that sometimes bones need a little bit of help to regrow. You can have pins, you can have a cast, but your bones are gonna be okay. Your bones do regrow. Your bones are really important for your body. Not only do they provide structure and do they protect your organs, but they also store nutrients like calcium, and you've got bone marrow. That's this little part here. You have bone marrow that produces red and white blood cells. So your bones are really important. Whew, you guys, we've covered a lot today. We've dealt with technology issues. We've seen skin. We've talked about the gastrointestinal system. We've talked about your bones and your muscles. Now, this is not, thank you so much, Willow. This is not,
Go back to your wrist.
we can go back if you want to see the x-ray. Let's see.
It's her wrist. She should.
There we go. Yeah, this is an x-ray. It shows I broke my radius right here, and these are pins going into my radius to help hold them in place as they regrow. So anyway, we've talked about a lot today. We've talked about skin, we've talked about guts, we've talked about muscle and bone, but that is not everything in your body. We're leaving out a whole lot of stuff, which, I mean, this is a university, right? I think we can do some superlatives, some yearbook superlatives. What do you guys think is the MVP of your body? What do you think is the MVP? I feel like I heard someone say brain or heart. Yeah, brain. I think so too. I think the brain is totally your MVP. You need your brain. The heart is a really good argument as well. What about most useless? What do you think is the most useless part of your body? Your appendix! Yeah, right? The appendix, apparently some studies are coming out showing that it holds some bacteria and nutrients for your body, but that is a great answer. I would also argue your wisdom teeth. Your wisdom teeth are pretty useless. Who's got their wisdom teeth still? Does anybody still have them? Nice. Yeah. And then let's do most unique. What do you think is the most unique part of your body? Any thoughts? Yeah.
Liver.
Your liver! That's a great answer. I'm not sure how unique everybody's livers are. I was gonna say maybe your fingerprint. Yeah, what do you think? Maybe your eyes, your irises. So, our bodies are beautiful and strange and unique, and there is so much more inside of us than we ever thought before, right? Thank you so much for coming and for hanging out and bearing with our technology issues. If you're really into the human body, I highly recommend you check out the Body Worlds exhibit that we've got or our mystery dissections here at the Franklin Institute. So thank you so much for coming. I'm going to be right here with all of these guts and this skin if you want to chat, or otherwise I will see you around the museum. Thank you all so much.